Just a very quick intro into some of the concepts that involve video and LED video. And then we're going to move into some of the more real-world applications, and finally going to show off a little bit at P3, just how to get a basic show file up and going, show off how easy it is. And in the meantime, if you guys have any questions while we're going through, feel free to raise your hand. I'll try to see if I can see. I'm kind of blinded right now. My name is Aaron Vengro. I work for Martin, which is owned by Harman International. I work on the product application support team, so a lot of the kinds of things that I'm going to show you are things that either myself or somebody on my team was hands-on with in actually helping the designer to build the system, get it up and running, and make it work. So the title of this presentation is obviously Not Your Father's Video Screen. One of the things to keep in mind when you're doing LED creatively and the needs for processing behind it is that creative LED is a lot different than just throwing up a normal rectangular screen. With a normal rectangular screen, like a TV or something like that, the pixels are always in the same place every time. The space between the pixels is always the same every time. So things like scaling, things like pixel pitch, are pretty easy. But when you can have creative video and you have multiple different pieces that have multiple different pixel pitches, different light output, it can get kind of complicated kind of quickly if you're not paying attention to some of those principles. So creative video can be found all over the place. For instance, these blue bars that are surrounding those boxes there are actually video screens. Again, they're just creatively put in there. This is the same studio, but they just updated their design a little bit. That center disc on the floor is actually a video screen as well. If you've ever been to the Omnia Club in Las Vegas, all these different pieces in there are all different pieces of LED video. So we've got a lot of different kinds of products in there, some dots and some strips, things like that. And what's neat is that this whole thing comes down in all these big concentric rings and then breaks apart and moves around, and the video is mapped on top of that to add a creative interactive element with that. Big thing we see a lot is trade shows. A lot of exhibition booths will have video elements within them. And then, of course, live concerts as well will have maybe not just a video screen, but then other types of creative video elements. So, for instance, on the sides here, these two curtain-like things are actually video screens as well. And then this was a really cool one, the Bentley exhibition booth. This was a product that we'll go over in a little bit. That was actually put behind all these different Lexan screens to add a cool color-changing video effect in the exhibition booth. Muse as well. This whole design on the floor is all different pieces of LED pixels that can be used either as lighting or also to run video content as well. And then this was Eurovision 2014. This was about 600 DMX universes worth of video pieces, but of course that was not run via DMX, that was run via P3. So a couple different things to talk about. A lot of times I hear 8-bit colored bit depth, 10-bit color depth. To kind of explain how color depth works is that if you have, for instance, a red subpixel, and it's only 1 bit, so it's either going to be on or off. If you go to 2 bits, now you've got on, off, and 2 shades of gray in between. Typically, if you have an 8-bit system, so you've got your on, your off, and then 250 some odd gradients in between. Once you have a red, a green, and a blue in 8 bits, you multiply the 256 by 256 by 256, and that's how you get your 16.7 million different color combinations. 10-bit, which is kind of a newer thing that you might see on a lot of TVs and things like that, is over 1 billion different color possibilities. Just to put that in perspective, the Martin P3 system supports 16-bit color depth, which mathematically is over 281 trillion different color combinations. It's good that if you have that capability, but it doesn't really help you a whole lot if you're unable to figure out what colors they are. For that, you need to see what the gamut is. So this here is a CIE 1931 diagram. The larger cone there is the range of human vision. And then the smaller triangle in there is typically like the HD TV gamut. And then over to the right, it'll show you how strongly certain colors are being represented in the output. And then again, it'll show you the different mapping points for where you're trying to balance your white. So the closer to the center you are, the more true of a white that you're going to get from that. And one of the things that Martin is very big on is factory color calibration. So next I have a video kind of showing how it is we do that and why it is what we do that. Oops. Let's see.
It's a well-known problem when using LED lights and video screens that you often see uneven colors across lighting fixtures and video panels. In this video I will briefly explain how Martin solves this issue, ensuring even color across all lighting fixtures and video panels straight out of the factory. Lighting manufacturers generally try to compensate for LED color differences by buying LEDs in so-called tight bins of closely matched colors. The problem is that even within a single bin, there are still noticeable differences between individual LEDs. When mixing colors, the problem gets exponentially worse. So for example, if you mix white using 3 different reds, 3 different greens, and 3 different blues, then you end up with 27 different mixed whites. Martin's solution for this issue is color calibration. In Martin's state-of-the-art factory, every LED fixture goes through our advanced calibration system. When the fixtures come in, our cameras and computers identify the actual color points of each uncalibrated fixture. For example, in this image you can see that in just one LED screen there is a wide variety of whites, even though the LEDs come from very tight bins. These differences in white would definitely be noticeable to anyone looking at the screen. The computer then tells every individual pixel exactly how to mix its particular LEDs to match all the other pixels in the screen. The result, as you can see, is that all the mixed whites come to a very tight point, with no noticeable differences to the human eye. This process is repeated across all lighting fixtures and video screens, and the information is stored on the LED board, in case the board needs replacing in the future. The end result on the wall is perfectly smooth and even color.
So next we'll talk about pixel pitch, resolution, and scaling. Pixel pitch, or sometimes expressed as pixels per inch, it's the amount of space in between the centers of the pixels in an LED display. So this is important because it has to do with the angular resolution of the human eye, which is about 2/100ths of a degree at 1 meter. Or a difference in pixels of 1/3 of a meter when you're 1 kilometer away from the LEDs. So it's really important too when you're picking out an LED system, what kind of resolution, what kind of a density do you want in your pixels for how far away the audience is going to be from being able to make that out. Because you also need to take into account what the overall resolution is going to be. So if you want a 4K system, but you're working on a 10 mil pixel pitch panel, that's going to be a 40-foot tall screen. So you need to take into account just how big of a screen that you want, how big of a screen you have the space for, what resolution you want when you're picking out the pixel pitch of whatever product is that you're going to be working with. Next is scaling, which is also very important because you also want to have the content fit the size of the screen. So for instance, on the left side there, my content is much bigger than the pixels that I have mapped, meaning that I'm not seeing all of my of content that I might want to have on those different pieces. However, on the other side, now the content is scaled too small to where there are LEDs that are not being mapped to content because the content just doesn't exist in those spots to display any information. So you always want to make sure that you're paying attention to all those different things to make sure that your scale maps meets your video screen size, the number of pixels you have, and the resolution. The next thing we want to go over is compression. It's typically done a couple different ways, usually with a codec. Codec stands for coder and decoder, and there's a few really popular ones out there. There's H.264, 265, VP9. Some of the media servers have a more proprietary. I know Green Hippo uses FlexRes. And these work a couple different ways. So a lot of times a codec will say, okay, well, I've got a pixel here that's red, I've got a pixel here that's red. Chances are the pixel next door is also going to be red, so it just makes that assumption and doesn't save the color information for that specific pixel. Or it may say, okay, well, on this frame, this color was red, and on the frame after that, the color is also red, so the frame in the middle, we're going to assume that's red as well. Another way that does it is by actually reducing the amount of color information that's in the frame. Because the human eye perceives color changes, we're less perceptive to color changes than we are to intensity changes. So if you look at the top row, all those images kind of look about the same, even though the resolution for color information has been taken out. But once you take away all the color information and you can actually see just the intensity values, you can see the one that's on 411 versus the one that's 444 looks very different, even though up top they look relatively the same. And so that's a way when you compress your images that you can save a lot of bandwidth. But then you might also sacrifice image fidelity as well. So the trick is to, when you're picking out a system, something that's not going to also recompress whatever it is that you're sending it when it sends it down the line to your LEDs. Next, we want to talk about frame rate. So the human eye is capable of seeing about 10 to 12 frames per second until you get as individual images. Once you start getting above 12 or 13, about 18, an effect takes over in your brain called beta movement, where your brain just kind of draws the information in between the two different images that you're seeing. So for instance, on this little graphic here, you can still kind of see how the 15 frames per second image is kind of jumpy, but it kind of sort of looks like it's moving. But the 30 looks pretty good, because now at this point, your brain has taken over and there's a lot of beta movement in there. The 60 frame looks pretty good, and the 120 frames per second one looks really good also. And you'll notice that the reason why the 60 and the 120 frames per second balls look the same is because something called hertz. The hertz is the number of times per second that your display is going to refresh. So most TVs nowadays are between 60 and 240 hertz. You have computer monitors that can do up to 240 hertz. Most projectors these days, though, are still usually at 60. But with LED walls, there might be some that are 60, there might be some that are 20, there might be some that are up over 3,840. You always want to make sure that your frames per second is evenly divisible into whatever the refresh rate is of the LED system, because otherwise you may get image stuttering, you may get image tearing, to where just for a split second you're seeing two different images on the same refresh because the frame is being drawn at two different times. So it's really important that you kind of always keep that in mind what the refresh rate of your display is. Okay. So we talked a little bit about this Eurovision thing and how that would have been over 600 universes of DMX. The difference between DMX and P3 is that P3 is an Ethernet-based video protocol. So the entire frame from pixel 1 to pixel 2.3 million something is all synchronized. And the delay between that first pixel and the last one is about 2 milliseconds. So it's really imperceptible. And so you can see how important that is, because for something like this, where you would have had hundreds of different universes of DMX, and so they would have been in and out of sync, only running at 30 frames per second, but here you'll see it running integrated with the video in the background. So I'm just gonna play this here. And I cut down this video a lot too, because it was like 3.5 minutes long, and this music is kind of annoying. So you can see how every single strip is all taking place at the exact same time. There's no lag in between. So you can see how the video on those strips is all playing together with the video in the background. I mentioned a little bit how DMX isn't the best protocol in the world for running video content, that there are much faster and better solutions available. However, we've also recognized that just for a lot of people's compatibility's sake, or what they're used to working with, or depending on how it is that they want to use their project, that we need to add some DMX capability back in. So one of the things that we're doing on some of our existing products and all of our products going forward is that you can do both P3 mode and DMX mode at the same time. If you're pixel mapping on your MA, or if you're pixel mapping on something else, and you want to do it over DMX because you want to have the same thing going to all of your moving lights as you are going to your video products, you'll be able to do that now going forward. The reason why that's important is so our new Mac Galore, for instance, that's 7 pixel mappable pixels plus pan, tilt, intensity, color changing values, everything. But when you have 7 different pixels, then you also have to have a fine and a coarse adjustment for for red, green, and blue within that pixel, which means that now a fixture that you might have only expected to only have 20, maybe 25 DMX channels now has 65. And so that's when DMX limitations really start to show, is because the DMX universe, you only have 512 channels. So, and the atomic dot, which we also have over there, is even more channels. That's closer to 98. Our MH10, which has 24 pixel mappable pixels, is 98 channels of DMX. So if you want to have that kind of control over DMX, it can get very complicated very quickly, which is why we created the P3 to allow you to pixel map those things very easily. You just drag and drop it, and I'll show that off later. So we're talking about P3. There's 4 main variants. There's the P3 PC version, which is what I'm going to be showing off, but the software is identical to the 3 different P3 hardware boxes. So up top is a P350. It's physically identical to a 150. With the 50, you can get up to 100,000 pixels of control. The 150 is 500,000 pixels of control, and the 300 is over 2 million. So that's going to be a full HD wall. You can also run P3 PC on a media server as well. So we have a partnership with Green Hippo to where if you're running P3 PC on a Green Hippo media server, it automatically maps the output from the Green Hippo straight to the P3 software. So you can use your media server and send it out to your fixtures over one single Ethernet cable. You don't have to have a piece of content being output from the media server to a controller and then being sent out somehow over DMX or something else. So it's very easy, very seamless to set up. On the back of the P3, you've basically, on the 150, and the 50 and the 150, you've only got DVI in. You've got some space for your user interface. You can have 5-pin DMX going to it if you wish, or ArtNet. The P3 300 is a little bit different in the sense that you get a lot more capability with it. So you get 2 3G SDI inputs. There's also 4 P3 outputs. You can also run a Genlock source if you wish. And then you can also connect it to a web server as well and for remote management. Once you get out of the P3, it goes to a power supply via Ethernet, and then the cabling from the power supply to the fixtures is very easy. It's one cable, power and data. So there's not a whole bunch of different junction boxes to get to the fixtures. And the cabling is also IP65 rated. Most of our fixtures are IP65 rated as well as far as the video stuff. There are a few that aren't, and those are more for indoor installations. But it uses a quarter turn connection, so it's very, very easy. So there's 3 different power supplies as well. There's the P3, the PowerPort 1500, which is ideal for rental, touring, temporary type installations. Then we have the install, which is obviously more for a permanent installation. That's actually the College Football Hall of Fame down in Georgia. This one is IP65 rated. It's made to be permanently installed and then forgotten about. So you can just leave it in a closet somewhere, leave it outside, it'll be fine. There's also a rental version of that IP1000 as well, where instead of having the XLR4 connections in the back of the PowerPort 1500, it just has the BBD. So there's no adapters or anything to buy. You just plug it in and walk away. The PowerPort P3 1500 could actually power a lot of stuff. So depending on what model of Septron, you can get anywhere between 40 and 160 meters of Septron off of that. Or if you're doing a permanent installation, you can get 128 VC strips or 252 VC strips. Again, it just depends on how big of the installation is that you're doing. But this would be a typical system diagram for just the P3 stuff. So it's just signal from the P3 to the power supply, and then straight from the power supply to the fixtures. There's no adapter boxes or dongles or anything in between, which is a lot easier than if you're doing with, say, DMX system, where you've got to run power to the devices, and then power to the DMX devices, and then DMX from the DMX adapter to the fixture. So it's a lot less cabling. It's very simple, and it's all synchronized as well. Again. So here's a little bit more expanded system diagram, to where you would have your video source going into the P3, and then from the P3 either straight to the video wall, because the video wall is going to have its own power supplies, or to a power port, and then all the different creative pieces going in there. If you want to add in a lighting console, you can. If you want to have DMX control over the video content. And then also if you want to add in integration with automation. So Kinesis, Tate Navigator, it's also supported in P3 as well. And what that's cool is, I will show you this slide, this video. So what you'll see here is that the sticks are actually moving against the static background, and it's changing what's going on in the image as it moves up through the background. Does anybody have any questions? I'm going to swap over here to the P3 software, and we're going to go over just how to set up a show file really quick and get up and going. Let me. Okay. Oh, I guess I should show you guys this real quick. So when you launch P3 PC, first thing, the P3 PC software is free. Anybody can go to Martin's website and download it right now and get playing with it. If you want to actually use it to get output to the fixtures, you will need a little USB license key. I don't have any fixtures up here, so we're not going to be doing that. But if you want to, after today or the weekend or sometime 5 months down the road, if you want to play around with the P3 software, it's totally free. You can just go to our website and download it. It's also really useful if you're going out on a show that's going to be using a lot of Subtrons and things like that, and it's going to be running P3. You could download the software and build your show file comfortably in your home and you're in your office, and then you just move it from your laptop to the box when you get on site, and that way you don't have to sit here and do all the programming once you're on site with the show, because you can't always do that depending on who's loading in what. So when we launch P3 PC, first thing it's going to ask me is which network device do I want to use for P3 out. I'm just going to leave it as none right now because I'm going to be using it offline. Thermal throttling, it's something I'll kind of go over very briefly, but basically if you're in a situation to where either electrical load is a concern or somewhere where the heat is a concern, you can actually set the fixtures to never go above a certain temperature, and they'll automatically throttle back. ArtNet, if you want to select a network device to get ArtNet in from a lighting console, you can do that as well. If you're on a P3 hardware box, you won't get this screen because it's already got all the network interface cards in there, and it knows which ones they are already. So I'm just going to use all these offline. And now it's going to say, okay, well, what do you want to do? If you ever lose power or your controller resets, it'll automatically load your most previous show file after 10 seconds. But I'm going to create a new one. And I'm going to call this LiveCon. I'm going to hit Next. And now it's going to ask me what mode do I want to use. So you remember we talked a little bit about pixel pitch, and that's the space between the pixels on an LED product. Well, we make several different products that are the exact same physical size, but they have different pixel pitches, or they might have more or less pixels. So for instance, Septron, which is our probably most popular product, we make in either 1/3 meter or 1 meter. And then for each size, we also make 3 variants, either 40 mil pixel pitch, 20 mil, or 10 mil. So in the real world, those are all the same physical size. But in 1-to-1, it's going to map each pixel in the product to 1 pixel on the screen. So when that's done, you'll have a 1 meter Septron, which might be this tall on the screen, but the 1 meter Septron 40, which has 1/4 the number of pixels, will only be this tall. So you have to decide if you're in a mixed mode system, in a mixed system, how it is that you want it to be mapped, because it's going to also change the scaling for what pixels get mapped where. Because if you have a Septron 40 and that's only got one pixel every 40 millimeters, but you've also got a Septron 10, it's just going to not draw those pixels in between, those 2 or 3 pixels between the first and the second on the 40 that it might draw on the Septron 10, because it actually has those pixels there. So it really depends on what kind of effect it is that you're trying to create. So for now, we're going to go 1-1. I'm sorry, real world. I'm going to hit next. And then it's going to ask me what pixel pitch am I going to be working with. At one point, we had a video screen system that was 5.21. Now the smallest pixel pitch product we have is going to be 10 mil. So I'm going to go with that. And really, all this is doing is just a way to set the scaling mode that the P3 is going to run in, but also filter out fixtures that you're not going to use. So I'm going to set for 10 mil, and those face 5s are going to go away. And then it's going to ask me, what unit do I want everything displayed in? Do I want it displayed in pixels? Do I want it displayed in meters? I can do feet if I want. It's also going to ask me, what size do I want my workspace to be? You can set it to be, the maximum size is 1920 by 1080, or you can go smaller. Let me hit finish. So now we've got this large gray window, and that's the total workspace that you have for P3. But then you've also got this white window here, and that white window is going to be your active workspace. That's set from your video input, which we'll get to later. Over here, I've got the list of all the different fixtures I could possibly choose if I wished. If you're on a P3 controller and it's already connected to a power supply and it's got connected to fixtures, those will show up down here under Discovered Devices, which can be very useful. If you want to make sure that you have full connectivity to everything, you can go ahead and hit Tap Light All, and that will actually run through an RGB chase through every single fixture that's connected to the system. Over here, you can select your global brightness. You may think you always want to run everything at 100%, but I can tell you that if you're running a video wall inside a club or a bar or something like that, depending on the video wall, you're probably going to be running that between 2 and 7%. I've never gone above 7% on a video wall because it's dark and it just blinds you. You can also come here and set the gamma curves, and you can also set the global color temperature as well if you wish. So let's have some fun. Let's start plopping down some fixtures. Let's say for whatever reason, I don't want to have my fixture be 1. I want to have my first fixture start at 100. So you can actually change that here. And then when I put down my first fixture, it's going to be 100, then 101, and so forth. You can also set it so when I start placing fixtures, I'm going to go down to the Septron here. So I've placed one, but now it's asking me, it's assuming that I want to place another one, because I can just keep clicking and click and click and click and click. And you'll notice that it's automatically changing the address of the following one. If I want it to only do one at a time, you can just unselect this little multi box up here and select that to single mode. And now every time I click, it's deselected, and I can go back to doing something else if I want. It really just depends on how it is that you want to work. You can also, once you've got, let's say that you've got a handful of fixtures selected, or patch created. And now let's say that this is the first truss, but I need to put this on 4 trusses. You can actually copy and paste a whole other group of them over here, and then move them all together as a group as well. So some of the different contextual things that you might be used to working with on a typical Windows system or maybe even Mac or Linux. Also work here, so your Control C's, your Command V's. If I want to, I can even just hit delete and delete all of those at once. There's some other shortcuts in here as well. So let's say that my truss isn't going horizontally. Let's say that my truss is going vertically. I can just hit R. Oops. Why is that not working? Oh, I crashed. All right. So reload LiveCon. There we go. And then I can rotate it as well. So you can also set that rotation amount as well. Right now, its default is 90 degrees. You can set it for 10 degrees. You can set it for 45, anything that you want. So let's start over. So let's put some more Septrons on here. Actually, let's go back to 1. Okay. Does anybody have any questions so far? Okay. As far as moving around, working in the workspace, you'll see this little hand up here. You can go ahead and, if you click that, you can move the workspace around any way you want. It's whatever's convenient. But you'll notice that when that hand is selected, everything else is grayed out, so you can't actually do anything. As someone who has been working with this a lot for the last 5 years, I would like to tell you that you're always going to remember that. I don't. I forget all the time, and I think my controller's crashed, and it's like, oh, the hand's selected. So if you're ever thinking that there's something wrong, it's probably that hand. It happens all the time. I get phone calls. It's surprising. You can also run the scroll wheel if you want. Zoom in and out. Just got to hold down Control like you would for anywhere else in a computer. Or you can use the hourglass. I'm sorry, the magnifying glass or the sizing. You can go back to default if you wish. So now we can go to our video input, and we can set, okay, what's our source going to be? Well, I'm on P3 PC. I don't have a DVI input. That's just going to be the default selected. But what P3 PC has that no other version of P3 has is that you can actually capture right from the screen. And you can show the viewport. So right now it's black because I don't have the dongle plugged in. But if the dongle was plugged in to enable the output, this black box up here would actually show whatever was in that window. Oops, show viewport. Whatever was in this smaller window. Another quick tip, if you're ever running a Septron system and you're trying to figure, and you're using P3 PC and it looks a little dim, it's actually going to take into, you see how this down here, these whites, it's dimmed down a little bit. It's actually going to map that onto the Septrons. So if you're ever wondering why is it dim, just turn off the show viewport and you'll see the full intensity of the fixtures again. Going back to DVI. So depending on the system that you're working, you may or may not need to configure your ED/ID settings. Typically, if someone is using like a home-built media server, I do recommend that they isolate their ED/ID settings to only the input that they wish. Because typically when a computer boots, it's going to go through several different resolutions. It's going to go through several different offsets within sending video signal to that screen, which can sometimes cause P3 to either move content over or not get the input signal correctly. Also, if you're using a custom hardware video scaler, that can also sometimes cause issues. So one thing you're going to want to do is uncheck all the different ED/ID settings that you're not going to use to limit it to just the basic one. So I'm going to leave that the same. You can also select your resolution. One of the things about P3 PC, you can only control up to 20,700 pixels with it. But just because you can only control that many pixels, that refers to the amount of output that you're getting to the fixtures. It'll accept a 1920 by 1080 input, either from the Hippo or if you're, have a 1080p screen. If you're capturing the entire screen, you can do that as well. Here's where you can also set the brightness, contrast, low light setting for the DVI input. If you want to move the viewport around, you can do that here as well. You can also do that with the hand. Oops. and move that around as well. And you'll see how you can change the offset. You can also change within the viewport how far on or off on the viewport it is too. So depending on the DVI signal coming in, even if it's a 1920 by 1080 signal, you can select where on that signal you're capturing the video content. Down here, all these different buttons are your presets. So let's say for whatever reason you have a P300, you've got 3 different types of video signal coming in from 3 different media servers, and for whatever reason you may want to either mix them somehow, or you may want to switch inputs. You can do that just by triggering some of these different presets via DMX. Or if you want to change your scaling option as well. So the scaling is up here, and right now it's set to the same scaling as the 800 by 600. Very important thing about P3, it is not a media server. It does not hold any content. It only takes content that is coming in and maps it out to fixtures. That's all it does. There is a scaler built in to where if you want to scale something down, you can. But because it doesn't have the kind of processor like a media server is going to have, it can't scale up. It's not going to draw those extra pixels for you from information that it doesn't have. So when it downscales, it does have the capability to ignore certain pixels, so you can scale it down to something that to whatever size you wish. There are some limitations with that. It can get really low, but it won't go any lower than 8 times lower. So if you have an 800 by 600 source, but you're trying to scale that down to for whatever reason to 50 by 25 pixels, it simply cannot go that small. So if we want to control a preset, let's say I'm going to have it be DVI, I'm going to keep this all the same. All you have to do is right click and hit record, and then it's going to ask you, do you want it to fade or do you want it to snap? This mask here isn't what you might think of typically as a mask. So right now, nothing is selected, and you would think, okay, well, I want to have everything be recorded in this preset. I don't want to mask anything out. That's not really what it does. The mask is asking you what parts do you want to save. So right now, if I were to hit save, it wouldn't save anything. So I want to save global screen settings, video input, my setup fixtures, setup device settings. And then I hit OK. And now let's say for this preset, I want to have the scaling be, let's go 400 by 300. And I want my video viewport to be 200. And then I'm going to go negative 100. Oops. I'll go negative. I'll go negative. Okay, so what's the 100? For whatever reason, this is what I want this preset to be on this cue. So now, on 6 here, I just go to record, and I'm going to hit everything again. And I'm going to call this bad scaling. And now, so I can go to default DVI and go back to my normal settings. I can go to whatever it was that I had set on this one, and then when I click on bad scaling, it'll automatically call up that preset. And these can also be called up via DMX, ArtNet, and whatever. So we'll go here. Any questions so far? Okay. So let's say now that I've got a whole bunch of Septrons, I've got a whole bunch of allures and atomic dots, and it's kind of cool running video content in them, but sometimes I want to do something with them via DMX as well. So over here on this tab is where you would actually patch your fixtures in via DMX. So you can patch either one at a time or all of them, but let's just do one for now. And it's going to ask you what mode do you want. And so in intensity, it only gives you one DMX channel. It's just going to be intensity. You can run it in segment mode, so you can either run that fixture in red, green, blue, but again, it's the whole fixture. Or you can do basic mode, where it'll give you intensity and then red, green, blue. P3 was designed pretty much 100% as a video system. It was not designed to operate within DMX at all. So that's why when you patch it this way, it's for the whole fixture. It's not for an individual pixel level control, because if you have a system that can already do pixel level control over video, why would you want to do that over DMX? At least that was the thought when it was designed. Now, after a lot of requests from people who want to have that pixel level control over DMX, they still want to play video content, but they want to play with some of the individual pixels as well. That's being backported into the Septrons and Fatrons and things like that. So then if I were patching this, I would hit next. I would hit consecutive channels. I prefer ArtNet, so I would set my ArtNet universe, set my address, and then hit create controls. And right there, my controls are created. But let's say, I don't know, I forgot about a dimmer box somewhere and I need to change my address. It's as simple as just changing my address, typing it in, and it automatically changes the last address one used as well. If I go back to my setup tab and let's see if I put an allure on here. Yeah.
So when you're back on your DMX screen,
Yeah.
essentially what you're doing there is you're like virtually hanging fixtures and addressing them, and that's kind of how you would view it from the console perspective, right? So these are native to the video network, but essentially what you're doing is you're saying, oh, these fixtures are kind of like my conventional DMX fixtures that I would hang on a truss or whatever, and I would address
Yeah.
them. I'm just doing that virtually, and then I'm going to push my DMX control to P3, and therefore it will pass through the P3 network to the fixtures.
Correct. Correct. And actually, I'm going to do one with an allure to kind of show where we're going with the Septrons as well, to show why you might want to do that. So if I dump an allure on here, and now let's go to DMX in motion. So I've got my Mac allure, and now when I hit add controls, I have the intensity, the RGB, and the basic, but I've also got the allure basic and the allure extended. And these will match exactly what your fixture profile is on the desk. And that's something that you have to do. You have to patch it both on P3 and on the desk. And what P3 is going to do is when it's getting DMX information from the desk for controlling your allure, it will send that along with the P3 data as well, because the allure gives you the ability to choose either DMX or P3 or both. So I'm going to go with extended, and here you can see all the different channels that it's going to take up. And we're going to go consecutive. I'm going to set this one as ArtNet 2 and 1. Oops. So here again, it's showing you all the different DMX channels that you have available. Starting at channel 27, those are all the pixels, and so that's where you can set within your desk to accept DMX values in the fixture or accept P3 values, and that's just for displaying colors in the pixels. It will not, the P3 will not override even if it's in P3 mode. The fixture is still controlled via DMX for channels 1 through 26. Because it's getting those DMX values from the desk as far as pan, tilt, focus, gobos, things like that. And so it's this kind of capability that we're backporting into the Septrons, because maybe you want to run video content, but maybe you also want to have at random times strobes of random pixels on those Septrons to maybe have like a twinkle effect or something like that. Right now, you can't really do that. You would have to change it into video content for the Septrons. So that's something that we're backporting into the Septrons at some point. You'll also notice too that when I patched the allure in this Septron, it added a little extra icon over there to show that it's patched. So right now, I'm not sure if you can make it out, but it's RJ45 jack. But let's say I patch it in via straight DMX. Oops. We'll do DMX, and we'll do this. Yep, 1. So the icon there is a 5-pin XLR. So it's just a little graphic there to kind of show you all the how things are patched and so forth. You'll also notice that there's 2 little icons added up here. So up there, right now I don't have ArtNet or DMX going in, so they're gray. But if I were to have active ArtNet signal and active DMX signal, those would be green. This little dot here is also your status dot, because right now it's in orange, meaning I've got some fixtures configured, but I'm not detecting those same fixtures as being mapped. You'll notice that these fixtures over here are also orange as well. So if you ever add a system and you're not getting any output, those are two easy things to check. If those are orange, you've got a problem somewhere. It might be a misconfigured fixture. It might be a break in the line. It could be a lot of different things, but it's basically telling you, hey, I know something is wrong. When that's green, it means that every single fixture that's detected is also mapped. So for instance, under discovered devices here, if I had found some and I had drugged them on, even if it was just one fixture, that would change to green, saying, hey, everything's good, I've got all my fixtures, I know where they are. Any questions? Any questions about the DMX patching stuff on P3? Okay. So some additional settings that you can do here. You can also add in a background if you want. Let's say that you have a drawing or a photo of the truss and they're adding septrons. You can import that drawing into the P3 and you can dump your septrons right on top of that for easy mapping. You can also set your IP address for the DMX in motion there. And then also there's another place to set your EDID settings. The background image is pretty cool. Let's say that you have a background and let's say for whatever reason your truss might be exactly 1 meter tall. If you're putting septrons on that, you can actually draw on there exactly how far 1 meter is, and the P3 will save that and adjust the size of the image proportionally onto the background of your workspace. So when you plop down a septron, it's exactly the same size as that truss that you've put on there. It just makes it easier for accurate mapping for wherever you might be trying to put things, or if you want to have a preview and show somebody else. Here you can set some of your different preferences. So you can change your live fixture color if you want. I just leave it as the default red, but if let's say that you really like green, cool, you can change it there. You can change your grid spacing as well, which are these little dots back here. The default is 25. I typically go to 4 just because I like knowing where pixels 1 and 5 are. You can also turn on or off the snap feature, which is if you've got a whole bunch of fixtures that maybe are sandwiched next to each other, when you're drawing them, it'll automatically snap it to the next one. You can turn that off if you don't like it. You can also display flexible fixture dot information as well, just depending on wherever you want the anchor for where that fixture when it's rotating around. And then you can also change your network settings there as well. If this were a P3 box, we would also be setting IP information for ArtNet coming in. We would also be setting additional IP information for if you're running the web server. But none of that is on the P3 PC version just because it's already a laptop, you're already sitting at it. Also, here's where you would select your, uh-oh, we're gonna crash again, there we go. Your fixture firmware library. So every new release of P3 that we do, we also include any fixture firmware updates within that software. So P3 is about 50 megabytes. So the fixture profile is only a few kilobytes. Every time that we update fixture software, if you have fixtures on here that have old software on there, right down here under discovered devices, it'll say devices with incorrect firmware detected. You can either choose to update the firmware or not. If everything's working fine and you don't think you need to, cool, everything will work just fine. If for whatever reason there might be an issue, we could try updating the software, we can try replacing it. You can also roll back software here as well. So if you want to roll it back to a earlier version, you can. You just drop down this menu, which is a little finicky. And you can select an older version of software if you want, and then you hit reload, and it sends it to all the different fixtures one at a time. Just as a heads up, there is a weird bug within P3. If you're updating the software for 15 fixtures, each one takes about 10 seconds. If you select 50 fixtures, for some reason, each one will take a minute. So I recommend doing in chunks of less than 20. It'll actually save you, it's a little more labor intensive, but it'll save you a lot of time. Unless you can walk away from something for like 45 minutes. In that case, do all 200 fixtures at once. Over here, you can hit color targets. So I don't have any fixtures plugged in right now, so it's not really going to do anything. You can actually set the color target for individual groups of fixtures if you want. So for whatever reason, let's say that you've got fixtures that might be behind a fabric or have different lensing, or for whatever reason you're using somebody else's products and you're using our stuff on P3, and the color temperature is a little bit off. You can actually set where you want our stuff to be at to match everything else that might be in your rig. There is something here built-in called Fixture Adjuster. So if you remember in that video about color calibration, where everything's color calibrated from the factory to a spec, that's true. However, LEDs age depending on where they're used and how they're used. Like if you have it running in blue for 5 years, when you switch that to white, it might be exactly the same as it was from the factory. It might not. Everybody that says that their LEDs are rated for 50,000 hours, there's really no way to test that, because that's like 20 years. So in the event that for whatever reason LEDs age, or let's say that you get a brand new one, or you're cross-renting or something like that, there's something built in called Fixture Adjuster, to where you can actually change the output capability of your Septrons. So each Septron, when it leaves the factory, is not running at 100% of what it's fully capable of doing. We actually dial it back about 20% just to get longer life out of the LEDs. But let's say that after 8 or 9 years, you're running your Septrons, they don't have the same kind of punch. You can actually boost those back up to an additional 20% and get a little more life out of them. We don't give away that software. It's an additional license, because as soon as we tell people, hey, you can get 20% more, they're automatically going to do that right away. And then suddenly the product might start failing within 4 or 5 years instead of 10 years. So also, that fixture adjuster, it's a permanent adjustment. So if you're cross-renting it and you do it to whoever you're renting these additional fixtures from, and they don't have that fixture adjuster software, now they can't change their fixtures back to what they were previously to match the rest of their inventory. So it's something that we're very, very careful. We don't give it away. There's training that goes along with that as well. However, it's possible that you can make a temporary adjustment. So down here, once I've got all these Septrons selected, you'll see intensity, red, green, blue. You can adjust those to whatever value you wish. You can go from 100% to 0. So let's say that you're cross-renting and their fixtures, for whatever reason, have aged or were left out in the weather for a decade, and they're not as bright. You can actually dim yours down to say only 80 or 90% and try to match it, or even adjust the red, green, blue and do the same thing. However, this is only saved to your show file. So as soon as you start another show file, that information is not going to be there. And that's why it's different from the fixture adjuster, because that's permanent and it saves to the fixtures. Any questions? Okay. There's also, of course, different test patterns if you wish that you can run. Just hit play, and then there's white, red, green, blue, moving lines. I use the moving lines a lot, especially in a Septron or VC strip, something that's only 1 pixel wide, so that I can kind of see the direction that everything's going. I did this project about a month and a half ago in Seattle, where they wanted a circuit board design, so it was 1 pixel wide, and it was hundreds and hundreds of devices that were on this big ceiling, and it was trying to figure out, and the contractors had put some of them in backwards, had broken different ones in different parts, and I used the moving lines test pattern to kind of just see what direction everything was going in, and just look for the one that's different. And different test patterns have different applications. It's whatever one that you find useful. There are some additional wizards built in as well. So let's say for whatever reason, you want to maybe create a layout. This wizard's not particularly flexible. It can really only do certain shapes and sizes. So unless you're doing a video wall or something that's a very rigid square or rectangle, I don't really recommend using it. I just don't think it would be particularly useful in a creative application. Oops. Click this part of the mouse. So let's pick Septron, and we'll hit next. And then, yep, I want to add it to a group. And I'm going to do 20 wide, and I'm going to do a height of 2. And it's going to give me a preview. It'll actually ask you to, like, what direction is your daisy chain going to go? If you have multiple lines going out there, you would select multiple daisy chain network switch being used, and you can also select your start number. So we'll hit finish. And then it's going to put it up there. And you'll notice that it's got this little green, let me zoom in so you can see it easier. So I don't know if you can tell on there, but it's got this little green box around it. And that's what that does is it makes it easier just to select the group and then move them all around as groups instead of having to make sure that you've drug your line over everything and make sure that nothing's been missed when you select it. And you can unconfigure the group if you want. You can also name the group, of course. You can change the color. You can change the anchor position as well just by selecting these. So if you want to rotate it then, it rotates around that pivot point. Or you can set it to be the center, and it'll rotate around the center, just however you want. The next wizard is the video input wizard. It's very easy. It just basically helps you set up the video input for your P3 box. You wouldn't use that on the P3 PC software because it only has the screen capture capability. But the one that is extremely useful is the quick addressing tool. Let me ungroup these. So the quick addressing tool, let's say that, oh, it's because I don't have anything connected. So the quick addressing tool, the way that works is, let's say that I had built this huge Septron system and there were, 500 Septrons. So go through those one at a time and select them manually would be very arduous. Or you could use the quick addressing tool, which will go through it automatically for you. And when you do that, it'll ask you, there are some configured devices on here. Do you want to take away the address? Most of the time it's going to be yes, but you can choose no if you wish. And then what it's going to do is every fixture that's on the network, it's going to turn blue. And what it'll do is the first fixture it detects on the first output of the power port, it'll turn white. And then it'll say on here, what you'll do on here is click that fixture on your layout that's white in the rig, and you just kind of go through the line. And you might have to, if you can't tell which one it is, it's okay. You just hit skip, go to the next one, and then you run it again. And once it gets the last fixture in the line, or it only has a certain number of fixtures left, it automatically knows, okay, I know where everything is, and it'll finish. So a lot of times you might only have to run it once or twice. Let's say you've got 200 video panels. The first one you go through, you select 50 panels. The second one you go through, you might only select 40 panels. And then after that, it's done. You don't have to run it again most of the time. It's one or two passes. It takes about 5 minutes to configure where 200 panels are. All right. I know it's hard to tell without having anything connected. Any questions? Okay, well that's really about it for the presentation. Again, it's a basic intro into P3. Sure, yeah, over at the Martin booth we have the McAlure, we have 4 variants of the Septron, we have the Atomic Dot, we have some Dottrons. Everything is running in P3 and DMX mode. So if you like, come by, check it out, get some hands-on if you want to actually see how some of these wizards work that don't work when you don't have them connected. I don't know, maybe say hi. All right, cool. Thanks, guys.
All right, we'd like to thank Aaron Vengrove from Martin Lighting and thank all of you for coming out as well. If you have any further questions, we will be at the booth with Harman Professional and Martin Lighting. If you have any further questions, want to see some fixtures. And whenever you think of lighting, think of Martin Lighting and think of Live Technologies for your needs. Thank you.